So this is our testing equipment. Okay. On the left here is the vibration table. I will talk about this first, and then over to the right is the thermal vacuum chamber. And let me start with the vibration table first. When you launch a satellite or anything into space, well, you deal with vibrations from a rocket, right? Because the rocket is not going smoothly up into the sky. It's a very, very rough ride. And you can deal with accelerations that are 25 times stronger than the acceleration on Earth. So 25G or even 26G. So the problem here is that with these vibrations, you can actually tear the satellite apart. In particular, you will loosen screws. And these screws can be very, very dangerous because they will shred your satellite pretty much apart. Now, when we talk about these vibrations, these are basically like ultrasound vibrations. And every rocket has its own pattern. And we have the pattern of these rockets in our computer here. And our computer controls this vibration table. Now we can fix the satellite on this vibration table and then see if every component is fastened enough that it doesn't fall apart. Now we had these cases that then sometimes there are a screw loose, and then you shred really, literally speaking, your satellite apart if that happens. Before you do this with before you launch a satellite, you want to test this out on the ground because, well, you don't want to lose millions of dollars for a satellite that you launch into space, and you want to find out if there is some kind of design flaw with your satellite that you can fix still while it is on Earth. And that's why we use that vibration table. Now, the next thing is when you launch into space is you are dealing with or not dealing with air pressure anymore, right? Because here on the ground we deal with air pressure and it holds everything nicely together. Now, when you are in space, and you notice that already when you drive over mountains, that your ears pop, right? The same thing. All of a sudden the air is gone. And what this means is that in the components that you have on the satellite, they are still under air pressure. So they have to get the air out as quick as possible. And in order to do this, well, we test this with this thermal vacuum chamber. So we suck out the air very quickly, and we can see if all the components hold. Now, the second thing of this chamber, it looks like a TARDIS, right, is that we can heat up the satellite from one side and cool it down from the other side. Because when you are in orbit, not only that there is no air pressure, but there is also heat, right? You heat up the satellite from one side, from the sun, and on the other side, well, you cool into 3 Kelvin into space, right? So you have thermal stress on the satellite as well. And what this means is that with this thermal stress, that parts on the satellite age really, really quickly. And we can simulate this with our thermal vacuum chamber. We can simulate basically 1 year in orbit by 10 days, having a component for 10 days in this thermal vacuum chamber. Again, the air pressure is also important, that we simulate the reduction of the air pressure, because on every satellite you have also things like cables. And cables have softeners, and these softeners will simply evaporate out of the cable primarily onto your detector, because that's the unit that is usually cooled on your satellite. It's like you take a can of soda out of your fridge and put it on the table, and you see the condensation outside on the can, outside of the can. Well, we see the same thing with the satellite. If we have a detector and we have too much outgassing, what we call outgassing, from the cables and from epoxies and all this stuff, and that can really ruin your experiment. And we have seen this with previous experiments, that this happens, and then your detector is not as good as it's supposed to be anymore. So that's a problem, and we can test this. So you can be very messy, but if you are too messy, well, NASA doesn't let you on board. Very simple. This is not because of your mission. They are not too concerned about your mission, but they are concerned about other missions, of course, because you are flying piggyback with something like a several $100 million or $1 billion satellite. And of course, they don't want that you, with your little $500,000 satellite, ruin that $1 billion mission. So in order to avoid this, you have to have a thermal vacuum test. And that's what we are doing here. That's also led by our students.